Well, I'm lucky enough to have what I think is the best day job in the world. I'm a fighter pilot in the Royal Air Force, so I've spent a career flying fast jets, and I still work full-time for the Royal Air Force, or as near full-time as I can fit in, because of course I've got a very busy, an increasingly busy hobby now, my holiday job, which is helping to design, build, and this year drive the world's first 1,600 km/h car, which is the Bloodhound supersonic car. So a very, very exciting year for us. Well, I was lucky enough 20 years ago, when the previous project was launched, to get involved through a driver selection process and eventually be selected as the driver for the world's first supersonic car, the Thrust SSC. In 1997, we set what is still the current world land speed record, 1,228 km/h, the first and still only supersonic record. That's going to change later on this year because Bloodhound is going to go faster. But with that background, I've got more experience. In fact, I've got the only experience of driving supersonic. No one has ever broken a record like that. And working with the designer of that car and the systems engineer and the team manager and the project director, effectively, we've got the old team back together. I'd love to say we're all old enough to know better now, but no, we're going to do this one more time, and with Bloodhound, we're taking it to the limit of modern technology and to the largest, in creating this engineering adventure for a new generation, we are creating the world's largest ever engineering experiment, because we're going to be able to share it with tens of millions of people live every time we run. Bloodhound is physically quite uncomfortable. It's sort of 2G of acceleration, 60 km/h per second. 3G of deceleration, that's 100 km/h per second. If you picture driving at 100 km/h, which as I say is not going to happen in Mexico City, but out on the... unless you're a taxi, of course. But if you're doing 100 km/h, that's coming to a complete stop in 1 second. That's a very violent manoeuvre. For me, that will be a normal day in the office at Bloodhound. So physically, I'll be training in an aerobatic aeroplane, getting used to that kind of G and the noise and the speed, the acceleration. But mostly, it's not a physical challenge. Mostly, it is a mental challenge. There is so much going on. Not being distracted by the extreme noise and the heat and being strapped into a small cockpit, the incredible rate of change, the fact that the car is sliding all over the place at 600-700 km/h. It'll feel like driving a car on ice and snow, which you probably don't get much ice and snow in Mexico, but trust me, it's a very slippery surface out on the desert out in South Africa, like driving on snow, and the car will be sliding. So I'll be fighting the steering at 600 km/h at the point where we're firing the hybrid rocket and accelerating at 60 km/h per second. All of that, my background as a jet fighter pilot, training and doing some track racing and some car training, keeping up my training in aerobatic airplanes and my G tolerance, and understanding every single piece of Bloodhound science and technology, all important parts of getting ready for this year driving the car for the first time. Bloodhound so far has not run. We are still constructing the car, and its first ever runs will be later on this year in 2015. We'll be running it initially at slow speed. Slow speed for us is 350 km/h. On rubber tyres at the UK on a runway, and as soon as we've finished the 300 km/h testing, we will fly to South Africa and start some medium speed testing, 600, 700, 800 km/h, ultimately working up this year to 1,300 km/h and a new world land speed record. 1,300 km/h is about 100 km/h faster than the speed of sound. So the car will go supersonic, we will measure the shock waves, we'll measure the airflow, we'll see how the vehicle handles, how the desert copes with the shock waves around the vehicle and around the wheels. And then year two, next year, 2016, we'll put a bigger rocket pack in, and because we will know how the car handles, we will be able to modify the car, change the setup, to improve the car, to make it faster, safer, more controllable for the 1,600 km/h ultimate land speed record next year. The technology in Bloodhound is world class world leading in so many different fields. Bloodhound is part supersonic jet fighter, it is part Formula One race car, and it is part next generation space launch technology. So we have the world's best military jet engine from the Eurofighter, developing 9 tons, which is about 60,000 thrust horsepower equivalent of power. 60,000 horsepower under my right foot. So my right foot will control the jet, 60,000 horsepower. Fantastic. The space rocket, next generation space launch technology, hybrid rocket, we're jointly developing it with the world leaders, a company called Nammo. We will be the first person to use this rocket. That develops over 70,000 thrust horsepower equivalent, and that's under a progressive trigger on the steering wheel on my right hand. So the trigger is the throttle control for the rocket pump motor, a 550 horsepower Jaguar V8 racing engine from the F-Type R, and that in turn powers the rocket pump, which delivers then the 75,000 thrust horsepower. Total 135,000 thrust horsepower. From a standing start, the car will be 20 kilometres away, stationary again, 2 minutes after setting off. The technology to make that happen is the world's best, most sophisticated high-speed aerodynamic shape. We spent 5.5 years working with the world leaders, Swansea University in the UK, developing that technology. The wheels have been machined by one of the world's leading aerospace machining manufacturers, Castle Precision in Scotland, another UK company. They make the front end of Rolls-Royce jet engines most of the time. They're making our wheels to the same standard. That technology is just as important. They've built the fastest wheels in history. We've got the fastest aerodynamics in history. We've got the world's best military jet engine, and we're now developing the rocket. Take all of those world-class technologies and you finish up with a car that will do 1,600 kilometres an hour. For the next 5, 10, 15 years, Bloodhound is going to be the world's fastest car for a long time to come, and it's going to be a way of bringing science and technology to life for future generations. That's the legacy, to develop that science and technology interest in the 10-year-old girl who one day will go on to create something remarkable. It's quite difficult to describe supersonic flight because the distinctive thing about supersonic flight is that the aeroplane generates a huge sonic boom, and as it flies past you hear it go ba-bam. From the pilot's point of view, or in my case from the driver's point of view in the car, it's a bit like generating the bow wave on a speedboat. When you're throwing off a big bow wave on flat water, if you're in the boat you never feel it. Now if you go past somebody fishing on a Sunday morning and throw a big wave on him, throw him out, soak him and throw him out into the water, he feels it and hates you for it. But you never feel the bow wave because you're making it. And it's exactly the same thing for the pilot in a supersonic jet fighter. It's exactly the same thing for me in a supersonic car. So I am actually the only person in history that has never had a chance to hear a car making a sonic boom, because I've always been inside it. And that's not going to get any better this year because I'm going to be inside it again. The last thing, and actually the continuous focus of getting ready to run Bloodhound, and as I'm about to lift my left foot off the brake and push my right foot down to ramp the jet engine up to full power, the last thing is always making sure I've got all the details right, because I'm in a world-class car, the best straight-line racing car in history, being built by world-class engineers and world-class British engineering and innovation. And my driving needs to be up to the same standard as that technology and the same standard as the engineering, and I need to work to the same quality as the engineers. So the pressure absolutely is on me to live up to their standards and make as near perfect a run as I can, controlling the car, putting the power in at the right time, slowing it down at the right time, feeling what's going on, monitoring the loads. Every single run I have to get as near perfect and as near exactly right as I can. But it's my privilege to work with world-class engineers, and if I didn't enjoy that kind of challenge, I'd be the wrong person for the job. Once the car is slowing down, there's the initial relief that it is going to stop at the end of the track. And of course, when it does stop at the end of the track, that is not the end for me, just jump out and run away. I've now got to make as many detailed notes as I can because it's now an engineering debrief. And of course, for a record, you have to do 2 runs within 1 hour. So the first 1,600 km/h run we do will be the first of 2. And in stopping the car, I need to roll down to walking pace, full lock, 250-metre turning circle to turn the car around, line it up pointing the other way, and then we have 45 minutes to do what looks like a racing pit stop on something as complicated as the space shuttle to complete the record. So just stopping the car is only the beginning of part 2 of the adventure. Project Bloodhound is incredibly easy to find. If you put Bloodhound SSC or Bloodhound Land Speed Record, or even just Land Speed Record into Google, you will find we're pretty much the whole of the first few pages. Look for Project Bloodhound, have a look at the website. More importantly, when we start running the car, have a look at the live video feeds from the car and the live data, which is going to bring it all to life. Bloodhound is going to be everywhere over the next 2 years. Now is the time to get involved and share the adventure. We'll look forward to seeing you there.
Thank you, Andy. I hope you enjoy it.
Thank you very much.